Hello, welcome to Automat Live Coding. Welcome back after a week. During this week, I've been playing a little bit with the idea of simulating water. So, reason for this is that in our assembly environment, we have a couple of places where we talk about overflow, and I think water is actually a nice visual kind of feature that we could show there. So I wanted to improve the way that we render cards. So we have a card, instruction card, and our instruction cards, sometimes in the center, they have this circular condition. Like there's like a button, like a window inside the card where we can change like how the condition will behave. There are 16 types of conditions and 2 of them would involve water. One would be overflow, another would be no overflow. Right now, our conditions, maybe I can show them because we have most of the icons implemented. Okay, so this is how the conditions look like. I think we can, or maybe the shading is good enough now. So the button here imitates a hole in a card capped by a pane of glass, and behind the pane of glass you have a symbolic representation of what the condition does. For example, if a number is negative, then do something. If a number is positive, then do something. If a number is lower than another number, then do something. If it's less than equal. So there are actually 2 types of conditions for less than equal or greater than equal. So there are those, they rely on signed numbers. So the positive axis and negative axis, they have different colors. And there is this one which is used for unsigned numbers, which can be very, very high. And for those numbers, we have slightly different representation. Yeah, maybe all of those should be red. Instead of going into purple. Purple is too similar to blue, I think. So we have condition for equality. Equality works for both signed and unsigned ones, so it's represented using purple. It's a nice color that I think connects red and blue. We have non-equal. So we have the parity check. It's very rarely used. This condition is almost never really used by compilers. Usually when you want to check for 0, then you do, I think, this and not this. Honestly, it's a very strange instruction, a very strange condition to have. But still, we have this represented here. So this is how we represent even parity, and this is how we represent odd parity. Maybe we could change this icon to 2 flags. So we have the other types of conditions. And here are the overflow and the no overflow. So specifically this kind of gauge that we have here, it has sections that represent different values of a number. So on the right we have this gray area which represents 0. Then we have a section that represents 7-bit numbers, so all of the numbers that fit within 7 bits are represented here. Then numbers that fit in 8 bits, then 15 bits, 16 bits, 31, 32, so this is 63 bits. And when we need more than 63 bits, then this is where we go into this lower range. And this range is divided further to show how many bits do we need to represent negative numbers. So for negative numbers going up to, that need up to 8 bits, I guess. So negative numbers are represented funny because you have the most significant bit always set. But anyway, those 4 ranges here, they represent different sizes of different numbers of bits that are necessary to represent numbers. So the most negative number would be minus 128, which is actually which cannot be flipped to positive. Anyway, so we have this dial, right? And when we have a number, we can show this number as an arrow, as an indicator, essentially on this dial. And the thing is, when we are using signed numbers, then whenever a dial crosses this boundary here, this is when overflow happens. Because essentially we have run out of bits to represent a number. So this place here, I think we should represent somehow. I was thinking that maybe we could show a crack here, so there should be like a cracked line. And when we have this overflow, I would like this indicator to leak into the outer area. So I would like to have essentially spilled water spilling out of this indicator. So there would be that. For the non-overflowing case, I would like it to be filled with water. So we would have some water here. I don't actually know how we will represent still water, but when we move it, or when the indicator switches to a different value, then we will animate the water moving around. And water animation is something that I think will be super useful to have all over the place in Automat. It's like another very important utility that we should have. A decent way to animate waves. So I did some initial implementation. So I found a block. Let me find it first. I can show it to you. Very quickly, I should have it somewhere in my history. There it is. So there is this blogspot from like 12 years ago, and there were a couple articles published on this blog. They are mostly about wave simulation. They talk first about simulating simple pendulums, maybe not the earliest blog, but those here. And they eventually introduce more and more sophisticated methods for predicting, or numerically integrating the wave function. Wave function is not an easy one. We have sort of a wave already in Automat whenever we use waves in a lot of places. For example, here in the eyes are googly, and we are using essentially our own variation on the wave equation here. The thing is, for single pendulum or damped pendulum, the equation can be solved exactly. So we have a proper solution here. But for a string of chained wavy things, when waves interact with another, they propagate and they interfere with each other. So there is this thing that we have to account for. And because of that, the math gets just very, very hard. So there is no general solution for waves on a string or on a sheet of paper or on a cloth. So this has to be numerically simulated. We are simulating something like forces. Waves don't actually need forces to exist. Waves only need some medium that oscillates, some medium which has a velocity at each point and some amplitude at each point. And waves have this very beautiful equation, which is probably the nicest equation in math, this one. So if you actually read into what happens in this equation, it's very symmetric, right? The left-hand side and the right-hand side, they are almost identical. And the left-hand side tells us how the amplitude of the wave changes with time. So it tells us that the acceleration, so this is essentially the acceleration of the wave. On the right-hand side, we have this expression that says how the amplitude of the wave changes with the position. So this is essentially the curvature of the wave. And here we have on one hand side the curvature, which is amplitude in space, and on the other side we have amplitude in time. And the equation essentially says that they are the same. So if the wave is curved upwards, if it has positive curvature, it's going to accelerate upwards. If it's bent downwards, it has negative curvature, it's going to accelerate downwards. And the crazy thing is that because it's so symmetric, you can think of waves in a totally different dimension and they work the same. If you just flip this around, you can look at a point on a string in time, and it's just, how do you call this? I think this property is called isotropy. So if you look at this system from different position, it still behaves the same. So it's a really nice, it's a really incredible thing. It behaves the same way in time as in space. And it's crazy that the wave equation is essentially the foundation for physics. Light behaves like that. This is kind of how the universe behaves. And it's fascinating that time and space are interchangeable. Mathematically, at least. Okay, so the author of this blog then uses some tricks that I have no idea how they work, but he comes up with a different formulation. So it's using a finite difference, this finite difference approximation it's a technique used in engineering to solve differential equations. Yeah, he essentially expands the acceleration. So, and he uses some tricks which like I said, I don't understand. I don't see why there is this H star extracted at some point, but I trust the author. He knows what he's doing. So I'm going to scroll down to his result, the stuff that he ended up with. And this is it, essentially, this set of equations. And solving this set of equations allows us to simulate a wave. We can essentially plug our accelerations here and amplitudes here. And by solving those equations, we can continuously simulate the behavior of the waves. Super convenient. And when I look at this, I don't see velocities used anywhere. Which is strange, because velocities should be important here. Maybe they are part of this gamma? Nope. Okay, I think H star includes velocity. H star is the estimate. Yes, this is the thing that includes velocity. Okay, so we have everything here. So at each step of our simulation, we want to find acceleration, and we do this from scratch, essentially on every tick. I mean, not completely from scratch, at least not right now, but that's the plan. So we have this huge matrix A, which includes coefficients. Those are all knowns. We know those values, each of them. We can even pre-compute this matrix A, I think. K is... what is K? Yeah, we can totally pre-compute this. Then we have X and B. B contains the our height estimation, and X are the accelerations that we want. So I'm actually not sure how we could work on this. I have started GoPro, so we can work on paper here. But we have those nice... everything is nicely written here, so I think I want to take advantage of this, so I will make some screenshots. And let's put them here. So H star, we want H star. Maybe we have definition of C. No, we don't. So C is just propagation speed in space. Sorry, not. Maybe it is. Anyway, C is not a problem. So I have this and this. Automat I will close. Okay, let's make those screenshots. And yeah, this is pretty much all of the equations that we need to simulate waves. Yeah, none of this is relevant. I mean, yeah, we also have the final step. Okay, so the way this works is first we do this, then we come here. We are using the H star to solve this set of equations. And then we do the actual advance using this. So the top step is trivial, right? We just take current velocity, we add delta. This one is hard, solving for x. This is where we need those huge matrices. Actually, so those are the definitions for k and gamma, which can be pre-computed. So the fact that we can pre-compute the A matrix is actually super interesting to me. I actually thought that we would have some variables here that would change from iteration to iteration. If we can invert this matrix, then our wave simulation could be really, really fast. Okay, so the next part of this block actually shows how to solve this equation. Newer post. However, it shows the... Yeah, we want to do this. I had no idea we can do this statically. Actually, I just realized this now. This is going to be great, actually. Okay, so there are some, like they say, iterative methods for solving matrices. In the case of this block, the block uses the Jacobi method, which actually works in a lot of matrices. Typically, in a matrix, the diagonal will have the highest values, and when diagonal has very high values, this is when the Jacobi method works, and it relies on just starting by assigning the unknown values to zeros, and then just iteratively multiplying with this matrix and just finding the new values for acceleration over and over and over, and eventually they will approach the correct result. Yeah, so this is the solution for our acceleration. I mean, solution, this is the iterative approach. So we take bi, which is the result from this, and we subtract the result of multiplication by the matrix. And I am actually wondering, maybe we can vibe code it. I will try that. So before we start solving the solution, let me show you how the Jacobi method looks. I will just fire up my laptop. So we have a small prototype. I basically took the code and ported this to JavaScript so that we can see how the waves behave. Actually, so instead of just looking at the equations, because the code is here, it's just using processing, not JavaScript. Switch over here. Actually, no. Yeah, I will just copy paste it. I will open a new folder. I don't think I have anything for waves. You cannot see anything, but in a moment you will. So this is the code from the article, ported, and okay, it has some very slight improvements. Going to be our index, which just loads the water.js. I think now we should be able to look at it. Why is there no preview? Show preview, yeah. So this is our water simulation right now. It behaves wonky because I think I was playing with some things. Actually, it's okay if it's here. So I made it possible to move the kind of water container, and I'm introducing some extra constraints which make the simulation. So water waves don't behave like actual waves. So the stuff that we are simulating here, it's closer to simulating the pressure in the water container and not the amplitude of waves. Okay, let me change some numbers here because they are clearly causing issues. Strange things are happening here. We will investigate them. I don't think they are numerical stability issues. I think this is just a bug. It has to be a bug, because it used to work a short while ago. Okay, this tells me that the issue is not happening here. Yeah, I can refresh this. It's still going crazy. Okay, we are crashing. Why are we crashing? That's why I prefer to use this in a browser, in a proper browser. Okay, this DT isn't looking bad. Those are just initial conditions. The only other place where I've injected my own creative creative solutions is here. So if the values are lower than 0, I'm setting them to 0. Comment this out. Of course, it's not causing the issues. So this isn't causing the issues. So this could be causing the issue. But it's not. So this is the problem when we... Okay, maybe this dx is too small. It's definitely too small, yeah. This is the issue when I have to suddenly interrupt coding. And I don't remember what I was messing up at the time. Anyway, it behaves better now. So the thing is, when we have a wave propagation speed, right? Our solution assumes that values of cells other than the closest one are not going to have any impact on the current cell. Yeah, so lowering the dx, super important. Unfortunately, the waves are not behaving as fun now. So, okay, I will restore this stuff so that the waves always fill half of the volume. And then I will bring back this, which means now I can move this around and introduce disturbance. Yeah, they behave nice now. The simulation stopped, slowed, so I don't like that. It doesn't feel realistic. I think if you think of water in a glass of water, for instance, the surface of the water is incredibly flat. So I think we should either lower this, increase the wave speed, lower the dx, or lower the column count. Lowering column count makes the simulation faster. But I think this has the best effect. Yeah, the water has to be animated in a very snappy way. We don't want to have any sort of slow motion animation. I can move the water like that and have it slosh from side to side. But apparently when we go lower, yeah, we are getting those crazy issues. So this is apparently as low as we can go before we have stability issues. I think we still have some very slight, like now, stability issues. How about now? So the issues, they get more pronounced when we have higher DT. So if we animated this using smaller steps, the stability should also be better. Okay, but I wanted to change the way we do this solution. I don't want to have this Jacobi iteration Excel here at all. So I will start a new file. Do we want to use JavaScript for that? So the choice of language is important because the assistant is better in some languages. I think it could have more. I think the best math code is implemented in either Python or in C. I would go with C. Change this to CPP. I just want the AI to program the solution. I will try diagonal invert. Yeah, it can take doubles. Oh look, there is a C implementation. Okay, we are going to use the Wikipedia implementation then. No need to ask AI to do this for us.
TP Chica says,
Hello.
Hey, welcome back.
Speaking of AI, I want to hear what AI confabulated today.
So respect for using the proper terminology. So far nothing, but this is only because we didn't ask it anything yet. So I was going to ask the AI to implement this algorithm for us and I guess it would implement it nicely.
From import, weak instance stored.
By the way, VK instance, I think we are using a similar type in our code base.
Not gonna lie, that would be quite convenient. See preprocessor feature. Of course, then CP would have to have its own preprocessor because of namespace.
There are those modules in C++, right? And I was very hopeful for them for a long time. I did spend like a couple of weeks porting, for instance, the Automat build system to use modules to compile everything, but it was just so bad.
Anybody supports modules.
If you have just a toy program, then you can make it work with modules. But if you want to use like almost any external library, it's just going to be a huge pain. And the modules, they introduce so many strange... There are like 2 new formats of intermediate files now, of like precompiled stuff. It's just, I feel like modules is just shifting the responsibility for sensible compilation from the compiler to some other component outside of the compiler. The compiler should take care of modules internally. It's the way that they are designed in C, the way they are implemented, it's in C++ maybe, it's just very strange.
In my experience, for each external file you end up having one custom forward DCL file and one empty in file.
So modules, I said there are 2 different formats. Actually, no, there are 3 different formats. Because there is Apple specific, some precompiled header format. And CLang also has 2 other ones, like, again, one for just precompiling headers and one for precompiling proper modules.
Even AI freaks about CPPRG.
Yeah. Okay, I have no idea why this restrict is placed here. I know the restrict as a qualifier for Values that will not be aliased, but why? I've never seen it put in an array index. Yeah, let's see DeepSeek. Okay, this is actually a decent implementation. I like it. We could go with this one. But there is more, I guess, sophisticated one here. Oh, there is one for cyclic matrices. So we could have a wave that wraps around in a circle.
And now I'm even more concerned about AI's ability to moderate text.
Oh, you mean the fact that C++ is unsafe and it cannot be produced? Because it would be unsafe for the user? I think that's nice. I think that only makes C++ more attractive.
Message second before this one.
But accounting for this one?
Did I just restrict my First Amendment right? Ensuing robots party.
Yeah. AI used by government would be unconstitutional. Because it would prevent you from using C++. To hurt yourself, to shoot yourself in the foot. Oh, that's nice. And it even gives an example of Thomas' algorithm. Because we used Thomas here, and it probably knows Wikipedia. This is actually super fast. Solving for x is even faster than getting an inverse matrix, which is what I initially wanted.
And maybe coincidentally create an atomic bomb 10s more powerful than SAR bomb and throw it right onto yourself.
Speaking of this, I've been considering the method that I'm using here. So it looks like waves, it behaves like waves, but those are not... So technically speaking, those are waves. But waves on the surface of the water and waves within the water, like pressure waves, are a completely different thing. So here we are simulating the pressure behavior. The surface waves are a completely different beast. But it just happens that when we do this slow enough, they kind of behave like actual waves. So for example this, when I move it left and right, it looks like the water is sloshing left and right. But we are not actually simulating the water properly, we are simulating the pressure. So if I had a glass of water and I vibrated this glass at a very high frequency, like 1000 Hertz, so this is roughly how the pressure would behave. It would rise on one end of the glass and go to near vacuum on the other end of the glass.
So, technically speaking, you can extend the truth and say you are using so-called AI and get free funding.
Yeah, it's funny, but it's true. Government grants, for instance, you know, whatever deals with AI is bound to get them. Okay. Cyclic Thomas seems to be considerably, it has one extra loop.
Technically speaking, operating systems are just AI models running on bare metal and behaving like old-school factory management.
Yeah, like classical AI with logic and the chain substitution rule.
Can it have logic if logic had to be hard-coded somewhere?
Doesn't sound too logical. By the way, I was listening to podcast of the Future of Coding episode. There was one recently. It's not administrative, yeah. Anyway, and they are talking about very old paper by Turing, and I thought I disliked Turing, but yeah, it seems other people dislike him even more, but for completely different reasons. And honestly, the Turing paper, which introduced the Turing test, It doesn't seem so bad to me. I mean, yeah, it's more scrappy, but it's up to lower standards than the papers are nowadays.
I love his memory tape idea.
Yeah. So he's being criticized for not quoting his sources, like.
Granted, it was back in 1941, Dorsty.
Yeah. That one, for instance. So there have been computer designs before Turing. It's just he didn't mention them, and or even the Turing test. So apparently Turing was learning at some university at the same time as Wittgenstein was teaching there, and some of the ideas that Wittgenstein was teaching were kind of pretty much the same as in the imitation game.
But now we have hard disks that can behave like Turing's memory tape.
Except being infinite. It's one small thing. Although maybe when we get quantum computers, we get some kind of very fragile but infinite tape. So this is actually a nice metaphor to a qubit. So a qubit is like an infinite tape, or a set of qubits is like an infinite tape where you can write as much as you want, but when you want to read information out, you can only read one byte or one word, but you don't know which one you read. So it's like random memory access, but the memory access is actually random.
Quad state punch cards?
Okay, I like cyclic stuff, but in our case, in the case of our glass, it's not what we need.
I mean, RAM is random, but only after operating system occupies all of the addressable memory.
Oh, speaking of randomness, I was recently playing with the random instructions that we have. Let me file this up. So we have some instructions for randomizing stuff. Like this one. Can I run this? Yeah. Turns out this is incredibly slow. Just randomizing a register. This takes thousands of cycles. This stuff here. Let's do increment here. So here is how fast increment is normally. Right? it's about 3 billion or like 5 billion increments per second, something like that on my PC. But when I chain it, and let me zero this. Zero, please. When I chain it with randomization, it's like 200 times slower or 100 times slower. So it takes, okay, it takes about 100 cycles to randomize a number. I should probably measure this in a better way. No. What's happening here?
R5 8000, 500 is Zen for Arch.
I want to see how much slower it's going to be if I introduce randomization here. I think it's Zen 5. Is this my CPU?
Small L Splash says.
Hi.
Hey, hello. Okay, it's almost done. Or not.
Gunny, 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 gunny.
You know, I can just silence you.
DP Chica says.
It's in Twitch About You page.
Yeah, I think it's Zen 5. Okay, and it incremented this one. So randomizing a 64-bit register is about 100 cycles. About.
If it's Zen 5, that would explain slow random.
Yeah, register renaming sounds like a fun thing, like another can of worms that will probably open more exploits. Yeah, so this is Zen 5, but this is the lowest end of Zen 5. It doesn't have a lot of typical AMD extensions. I think it's Zen 5. Maybe I'm wrong. Anyway. Okay, I wanted to take this code and see if we can port it to JavaScript. Let's get rid of this. So instead of using our Jacobi solver, we are going to use this.
I would not like to see your nmem rack cx in my code.
Oh, I mean this register renaming as in the same way that, for example, the hyperthreading causes cache to leak from app to app. So application can probe another application's memory by checking the cache speed.
Given enough time, someone will make that instruction.
Okay, so this is the function that we are going to change now. We are removing this Jacobi something something. Very interesting. So when I just removed the simulation still does something. I don't know why. Apparently here we are doing something interesting. Okay, I don't know what I'm doing. I will just not do anything here. Here, let's go back to our acceleration estimation. So in our equation, we have those relations. So h star is this. We only need to calculate h star. We actually don't need to do this step.
Wait, what was the name of exploit found in GCC produced binaries when using std call function inside of cdtl function?
I don't recall that, but it sounds fun. So in Clang, the calling conventions can be arbitrarily manipulated. So if you play with Clang code, I mean not the API to Clang, but the Clang internals, you can come up with your own calling conventions to, for instance, randomize the order the arguments are passed into a function. That's a nice trick. Clang is such a nice compiler.
I remember this one explicitly involved racks and EX registers for whatever reason.
I could imagine some instructions clearing the upper half of the register and some not.
And funny enough, it only affected Windows.
Yeah, which is only Windows uses STD call, right? I don't know why it's in Polish. Okay. So we are using estimate height star. So this step is happening here. And we need to do this, which is Axel star. Oh yeah. Let's go back. I knew I forgot something.
I let compilers deduce calling conventions. I only care about them when I need read assembly.
Yeah. Okay, so here the math doesn't say so explicitly, but there is the A star variable also here. But this is just part of the Jacobi, or the Jacobi, sorry, not Jacobi, or the Runge-Kutta form works. Okay, let's grab our Thomas algorithm here. Let's call this capital Thomas. Let's use the same variable names. In this version we don't need Scratch.
Just remembered. It was USL escalation issue. Not particularly useful, because it would only be usable on Linux to force kernel to treat you as root
Yeah, that sounds nice. Yeah. I would say it's decently useful. This is something that would allow you to escalate from npm, random npm. So Linux root on WSL can still access your whole system. It still acts as an administrator. So this is a proper privilege escalation. Okay, I don't need to fill scratch with anything. I will just allocate it. Let and let here. Okay. Okay, so we have our array of x's.
But then out those famous 95 Windows users, how many of those are having USL installed and are not at least moderately security aware?
I would say that like most of like Node.js developers, they just don't expect npm package to be just a random npm package to be able to access a local system. Yeah, it's a fraction of a fraction, but the denominator for Windows user is massive. Maybe not the denominator, just the constant number. Like the population of Windows users is huge. Okay, there is something which is concerning to me, and it's that initially contains the input. I don't want that. This is what I want to solve. I don't know what's the value of x. Come on, why do I have to pass it here? And why is this used for anything?
Node's developers will be when they hear that Node has been running CCP code all this time.
Yeah. I mean, it's not wrong, right? It's just the interface is the most important thing. The fact that it runs C under the hood or assembly under the hood. Maybe not assembly, machine code. It's the interface that matters. Oh, it contains D. I see. So this is where we put our B values. Okay, that's good. I am unable to read a full sentence, sorry. Okay, let's directly translate those equations. So gamma is equal to c squared, which is wave speed times wave speed divided by dx times dx. And each value here is, okay, depends on what position we are. The first value is just...
They are. Wait, there is something lower level than nodeds.
Yeah. Speaking of, when I was younger, much younger, I learned about compiled languages. I read a book about C++, essentially. And the book said that as the compilers improve, the programmers will not need to write low-level languages anymore because compilers will do a much better job at optimizing stuff. Especially the dynamic languages, because a compiler which compiles some code into a binary doesn't have as much information. It doesn't know which paths are hot and which are cold, what are the most common values, what to optimize the code for. And that languages like Java, because Java was big at the time, have bright future ahead of them. Because the JVM, having access to all of this runtime information, is just going to produce much faster, much better optimized programs than any statically compiled language could. Yeah, and that was one of the arguments for Java, and I still think there is some merit to this. And JavaScript is a nice example because JavaScript has V8, and V8 can, like I remember this cool algorithm that they came up with where they, at runtime, they try to come up with classes that you are using based on, so if you start with an empty object, then you do a.x equals 3 dot something, a.y equals, I don't know, something else. It will generate a new class for you here when you create an empty object, like this is just a placeholder. But when you assign x, it will generate a new class which holds just a single float or just a single double. And when you assign to a.y, it will create a new class which holds a single double and a single integer. And the code which uses a from now on is going to be optimized to work with the memory layout of those like very tightly packed native numbers. So it's actually going to emit really decent code, maybe even better than if I designed this struct in C manually. Because on runtime it has more information, for example, about the ranges of values and so on. I mean, in theory it could do that.
Wait, why are we having comeback in low-level interest rate and dev community? Oh, it's Rust, never mind, they were right.
Yeah. Okay, so what is happening here? I think at each index, if I is greater than 0, we are subtracting. Okay, let's first fill it with zeros. So which is so this is the curvature.
Funny thing about REST compiler being slow, they are checking each and every possible code path to remove unused symbols from IR1 to IR2 and once IR2 when going to ER3. But also, they're running its code from ER2 to verify that all existing code paths can be.
Yeah, I thought this would be something that compiler would do in general. This sort of code liveness check. I don't know how all of the Slang optimizations work, but I know they have this. When you ask the middle end, like the optimizer, to do stuff, you literally have to say, do this optimization now, after do this one, afterwards do this one, and so on. So you kind of define what optimizations you want to run and sequence that you want them to run.
CCP compilers do it only when they are build so-called non-linkable objects for libraries.
Oh yeah, I see, yeah. Makes sense. This is why you use LTO, because I guess at LTO stage it can build a program like it was a library. Okay, so this is our value of B or D in this situation here. Okay, and it should look good. Let's also do kappa. Actually, no, let's now do the we need kappa. Oh yeah, actually kappa is the same as gamma times delta t delta t. And yeah, and this matrix is super clean. So let's do arrays for A, B, and C. A equals minus kappa. B is 1 plus 2 kappa, and C is another minus kappa.
I'm young enough to not know how it was back then, but old enough to schooled by guys who used to write linker scripts that would pull only one symbol from X into Y.
Yeah, linker scripts. This is the ultimate chiseling tool for shaping binaries. Always when I have to do something crazy, like extract a single function from a stuff that I built, linker scripts are fun, but they allow you to do some crazy stuff. Like, they give you so much control over the shape of the final binary. I wish they were more portable across platforms. Because effectively they only allow you to play. Okay, maybe I only know them for Linux. I don't know how this works on other platforms.
Conan, Gia, Talon Code Bitry.
I have no idea what's this one. Is this some... So when I remember linker scripts, they looked more like assembly. Essentially list of commands for which stuff to put in each section. Yeah.
XTZ.
Okay, so we filled our arrays, we called Thomas, now let's move it back. And that should be it. Why it's not working?
That's one way to use linker even though it falls into undefined behavior of link's choice tool.
Do we have a wave propagating? I think we do. But why is it so slow? Did they comment out something? Let me do... It's so strange. It's so strange because I'm using really low values here. Okay, it seems like this Thomas algorithm is working. It's doing something. It's doing this very, very slowly. Okay, and now it's basically stuck. What? But why? So when I divide delta t and make it smaller, the simulation gets faster. Still very, very slow. But you can see waves propagating. I can maybe feel the initial state differently. So I will comment out my Perlin noise and add some simple wave. Okay, a very simple wave, how it behaves. It's decent. We'll increase the column count from 32 to, let's say, 302. Super slow. It also looks like this wave speed doesn't have any effect. Oh, I see. I have to multiply the x values by gamma. I forgot this completely. Okay. Yes, multiply by gamma, and now, yes, now it's going crazy. But the wave behaves nicely now. So the initial wave, we started with a sine. It split itself into two smaller waves. I will make this smaller so we can see it. Let's do this. So we started with a large sine wave, but stationary. And it started wiggling back and like warping the space around it, and it split itself into two identical parts that are now moving outside, and they should reflect from the side.
I really love people talk about X and don't show implementation detail. Like, why talk about it then?
Yeah. I guess it's for maybe for not scaring people off. Sometimes this happens. Okay, so we had two waves which reflected from the side, and now they are overlapping. So for a brief moment there we had a stationary wave, like when it reached maximum amplitude it stopped, it was just a sine. So it kind of, we got our initial wave, yeah, and it behaves like it should in this medium. So specifically it behaves like a pressure wave in the water. Like, I don't know how to create this state normally, but yeah, it's essentially like a sound wave in the water. It's not a normal wave, like waves on the surface of the water, but it acts like sound would propagate. And because we switched to our new algorithm, this Thomas thing, so instead of having 20 iterations, so the Jacobi, so it iterated through all of the values 20 times. And it was doing back and forth, back and forth. Now we don't need that. So goodbye. By the way, this method is super simple, and it's something I always start with. Because even if the problem is super hard, the Jacobi almost always works. You just need to have very high values on the diagonal of the matrix.
Never mind, YouTube did the YouTube thing. Not loading comments for about 15 minutes.
Yeah, the comments are always far down on the bottom. Okay, so we actually switched to a better solver. Sweet. I was also thinking, when we have transforms, like regular transforms, are they tri-diagonal? So when we have a regular matrix...
Video in question
URL.
and related comment is first one.
And I've used it before, and it doesn't perform as well as
By the way, there is some marketing in naming of hash tables. There is this thing called perfect hash tables. There is nothing perfect about them. It's just how the paper was called, which introduced them. Oh yeah, it's also mentioning perfect hash tables. Perfect in a mathematical sense that you have two hashing functions. What? Who does this stuff with code? This is a joke. So, to be safe, you shouldn't even look at a code like that. The no derivatives is just such a strange condition. It's like against how humans work, how culture, how science, it's like the worst kind of license. Okay, we have our nice reflecting waves. Let's try to crank them up now. So, if I reduce this d, the waves will probably get unstable, but they will propagate 10 times faster now. And they are also not having those artifacts now. Strange, but nice. Oh, and we also have some numerical issues because they are losing energy. This should not happen. The wave should maintain the energy. It's probably because we choose too low delta x. Okay, and the crazy one. Yeah, the crazy one is crazy. Again, crazy. Okay, I think this is as fast as I can make it propagate. Now I can reduce the number of columns.
It'll just market it as unperfect, perfect, unhashable. TSV format then.
I should not do this with delta t. So over the past week I was reading articles on wave simulation and I learned some fun things about physics. So apparently this type of wave simulation is also used to analyze back reflections of high power lasers. So when you have a very, very powerful laser that shines light, like crazy powerful lasers, they have this property that they are self-focusing. So the light causes changes in refraction index of air, and it causes the beam to stay focused over very long distances, as long as the ray stays within atmosphere. It has to be probably at a border of, ionizing air. Anyway, this self-focusing also has some ripples along the laser beam. So the light, it focuses itself, but also a tiny fraction of the light is reflected back to the emitter. And apparently there is a way to use this to analyze, for example, the composition of the atmosphere. So by just shining light, like shining pulse of laser into the air, you can basically, and then analyzing the reflection, you can estimate the composition of the atmosphere. And if you can predict the wave behavior properly, so that you know where these reflections are coming from, you can even probe different positions along the length of the laser. It's a fun new device. Nobody has built one yet, but it's going to be interesting. Okay, looks nice. Okay, we lowered our delta X to super low value, and it seems stable. So I will bring back my sloshing code. Looks nice. So this is the typical type of wave that you would see in a small vessel, like a bead of glass filled with water. The water isn't going to do any kind of crazy acrobatics there. It's going to be mostly flat, with some ripples along it sometimes. If I shake it very quickly, I can create more interesting ripples. And there are some stability issues. But I think the stability issues will go away if I introduce damping, because there is no damping whatsoever right now. What do we have here? It's not bad.
Small L Splash says,
Gurney. Gurney. Gurney.
You know I can do that. Okay.
DP Chica says,
Speaking of Phi-6 and VAW simulation, one code base I don't recall the name, or if I was granted one-time access to see code, really influenced my coding style, and made me switch from IYU to include only what you need in headers.
Mm-hmm. Or even less. Yeah, it's decent. Okay, our simulation probably should do some more things, but I think this is enough. The stuff that we have in JavaScript now It works kind of decently. Oh no, there's one more thing I wanted to do. That one thing was to change the shape of the... Change the shape...
I'm in the team that writes Pragma region forward declarations.
Oh yeah, yeah. This is what I meant for even less than what you need. Forward declarations are so nice, it's like loose coupling. This is what kind of enables building library or having a header that uses some library, but if the user of the library doesn't, use the right function, they don't need to include the library. It's like a trick that allows you to avoid using macros. Really nice dependency breaking hack.
Why have 10 headers included when you can have 300 lines of forward declarations? But that also prevents accidental copies. Because you only use type as pointer or references by CPP spec notched.
Yeah, it's a nice practice. But it also prevents you from inlining stuff. I like inlining structs. I like to have a struct which holds other structs. It just feels better than having pointers everywhere. I know copies are bad, but having everything allocated as a single chunk just feels nice. It makes control of memory allocations easier. Oh, this new Thomas solver actually allowed us to have a pretty decent simulation here.
You know you can uninclude headers, right?
What? That sounds like some module propaganda.
A bit of preprocessor magic.
So what you would have does include doesn't take substitutions. Something like that, include macro.
You are on the right track.
Ah, like conditional includes. Yeah.
and to be safe on Death Header Guard.
Okay, here I essentially want a circle equation. Yeah, I don't need to use trigonometric functions. I can use circle equation. Just to show this, what we are doing here, I'm pretending I have a circular bowl of water, and the water will be inside, sloshing around, and the height at any point this is the x value. Okay, let's just call this R. Something doesn't seem right. When I is equal to column count minus 2, this is roughly where the water column should start. This circle shows the or actually I should do this differently. Okay, now we have glass with some water, but still the positions don't look right. Yeah, like the radius here is too large. Now it's good.
Ijukoni says,
Hi, my name is Ajuk. I just want to ask if you know any streaming services that provide live broadcasts so that I can have access to various streams every live. Could you help me somehow? Are there any websites, mobile applications, alternatives like Kick, Twitch, YouTube, etc.?
I know, you just mentioned a couple. Twitch and YouTube. There is also Algora. For programming stuff, especially. tv.algora.io. Yeah. I'm live now, but there are many other people here. Yeah. Actually, this isn't such a bad way to present water in a glass bead, because water should have surface tension, and if if the glass is wet, it should climb up the glass. So maybe this is good for pretending that we are in a glass of water, in a tiny glass of water.
TV and Gora, can you recommend me any more? Live.
The other would be Twitch. Twitch has category for programming. And YouTube is very good at recommendations. So Twitch is more hands-on kind of experience where you can pick the streams you want, and YouTube is more algorithm-driven. So sometimes it will just show you a stream out of the blue, and you have no control over it. It just happens. And also sometimes it will hide streams from you, so there is that.
Yes.
So if you want to kind of control your stream consumption, then Twitch. If you don't, then YouTube. But YouTube is still good for discovery. The algorithm isn't actually that bad. It's quite alright. Hide this. Goodbye. Goodbye, goodbye. Fill array. Apparently we are not using this anymore. Okay, this is the one I wanted to change. So expected volume is not going to be this anymore.
And where in Google can I look for such things in English services that provide live broadcasts? What do I mean?
One trick I sometimes use is Twitch versus something, and it typically gives you some interesting alternatives, like Gin, Kick, YouTube, Spasm, no idea, versus YouTube Money, Jinx, Tremor. I have no idea what are those things, but oh, and there is more. Kick, I guess Kick. I had never heard of this, but you also mentioned this. Rumble, another candidate. So this versus query is good for finding more of the similar things.
Thanks.
Oh. Okay, I think I should have saved this code before doing this kind of edit.
Or Test TV and Gorat. It provides live broadcast because I know Kick.
Yeah. Algora's nice. I don't know how they exactly operate. I think this is still in the like startup phase. They probably still have investors who fund this stuff. Because storing media is expensive.
TP Chica says.
Looks like well, SCD. Hazard pointer before STD. Scope T2 to appear. Well, get.
I heard those names. I remember they were interesting, but oh, I remember. Hazard pointer is the one which is deallocated on another thread, right? Interesting. I still don't fully comprehend hazard pointer. It's probably some like edge case of those highly concurrent algorithms. Okay, that sounds like a unique pointer. Okay. I still would like to know what's the use case for this. So it doesn't allow ownership transfer, so the ownership has to stay with the original owner, so why not stack allocation then? Okay, motivation. Is there more motivation?
Ideally, it should prevent scoped data leaks.
Okay. So the first argument is, I'm not quite convinced by that. I feel that type system shouldn't be used to do this kind of stuff. It just makes code more rigid. Because you have to overload more ways to pass your argument. I mean, you will probably pass argument as reference anyway. So this code pointer, it's not going to appear in any signature, I guess. Because when you want to pass data that's not owned by you into a function, you would still use a reference for that. A reference is the non-transferable pointer. So it's only going to use as a top-level kind of way to hold some value. Okay. Okay, maybe I kind of see the reason. Okay, good point. Private data in scoped pointer. Okay, so makes sense, okay. Maybe something like this could have place in standard library. If the API is going to be almost identical as unique pointer with the only difference being lack of release method, then maybe it's some sort of documentation.
URL.
But it's fun that this is actually not coming into the next C++, but hazard pointers may come. I mean, it's... yeah, this is like uninitialized memory access. Oh, you mean that storing this stuff in a scoped pointer will cause a crash here. That regular pointer would also cause a crash if you stored your data like that. Or maybe if it's about leaking secrets. If it's about leaking secrets to other functions, then it's a totally different problem. And
It should add stack 4 on line 7.
yeah, I know what's happening here. It's just the problem of hiding secrets between two blocks of code, or like two sections of code, or two libraries that execute in the same process. It has to be approached differently. Just pointer security isn't enough to guarantee that data will not be leaked. accidental leaks. Yeah. Yeah. Fun new pointer types. They are always welcome. Okay, I think we can port our code into Automat now. So I will leave this cursor window open.
If I recall correctly, it was removed from standard for same reason. CTD. Aloca is STD extension.
Okay, I think it would be nice to have a class that will do our wave simulation. So, okay, we have nothing dirty. Let's say wave 1D. I mean, we don't have any two-dimensional waves, but I think we will. So wave 1D is probably a good header to keep this. And how this could look. So what state do we need to keep? So when we create this, we need to pass some key parameters, like number of columns. And I think if this dx is constant, okay, so dt is definitely going to be changing dynamically. Only gamma is going to be constant. Okay, so our wave definitely needs a place where we will read amplitudes. And that should be an array of some size. So we only need to store the amplitudes and velocities. To have the wave reflect from the side, we will need to store 2 extra values actually. So instead of n, something like that, n plus 2. Can we do that? That would be crazy. So now we can use... yeah, it's just a fun way to access this stuff. Oh, I'm not going to do this. It's going to be too weird. Actually, no cost. Okay, the reason for that is that I want to be able to manipulate amplitude and velocity in fun ways. Okay, next we have the other parameters, like the dx. I'll close this. Can I use them in a template? I don't think I can. Yeah, I cannot. We need wave speed and the dx, and that's it. So this is part of the template. Okay, there are more states here, more pieces of the state. But I think they are used for readability purposes, and if we for example, used just height or amplitude kind of directly, then I think we don't need that many state variables here. Because really we don't use all of them. Yes, this estimate vel star. Okay, we need velocity pref. But all of this can be allocated on stack. Definitely need to store those things. Maybe dt will be the first argument. So this wave1d class only provides storage for all of the variables that we need to keep around. Okay. Actually, no, I should just remove this template argument. It's just crazy to have it here. I'm just moving stuff back and forth. Dynamic allocation isn't that bad. It's just single allocation. I shouldn't be this conservative about it. Okay, and here we can introduce some extra variables. Do this properly. Actually, we don't need to store more stuff. This is only necessary for the step function, and the step function will copy the data around anyway. Yeah, actually, it turns out there is almost nothing in this class, only step function will do interesting things. Okay, this stuff we can ignore for a moment, it's not relevant to us. Also damping. When do we use velocity? Okay, in accumulate estimate. Here in my hacky code, let's ignore this. You can also ignore this and this. So here we are only reading velocity, we are not writing to it into prev, into star. Here we are changing velocity, Newman boundary conditions. Okay, first and last are set to 0. Sorry, not 0. To the same value. Velocity prev, I guess it's used to estimate velocity star. Yep. Okay, so we need to allocate this much stuff. Unfortunately, we also need velocity star. Okay, maybe it's good to have some storage for it. So the first step of our update function, okay, we also have this height. I guess accumulate estimate changes height. Do we use height prev for anything? Estimate height star. Yep. Yes, we do. Ach. Okay, then we have this velocity star, which we can just copy normally. It's going to be used essentially right away. Actually, let's iterate from 0 to n. Add one here, just for readability. I'm not sure if it's going to be inlined. I hope it is. Can I say it's final? I guess now it should be inlined. I mean, it probably should be anyway. It's not virtual. Okay, so we made our copies. Our copy array looks fine. The next step is estimate height star. I will actually take this and turn this into a lambda. Okay, I don't think we need a DT. Okay, this height boundary condition is just about like setting first and last index. I will move this over here because logically it's part of this. Okay, we need this table for height star. So, velocity was estimated, height was estimated. The next step is estimate axle star. This is the hard function. And I will do it the same way. I will convert it into a lambda. Now we need this array of x's. Yeah. We will define it like that. This gamma, I will actually define it outside because it's going to stay constant for this whole function. Int here, int here. Actually, when I look at this matrix is also the same for each frame. We have this Axel star, which is basically the same as just Axel. It's just temporary acceleration. And these eggs, instead of copying this around, we could actually use Axel star to pass this value around. So let me leave a to do. Yeah. I want to first copy the whole algorithm before I start doing changes. Okay, now we have our Thomas, and I'm going to copy the Wikipedia implementation again, because it's already in C++. Sorry, it's in C, but who cares? Happened. Oh, so in C++ we cannot do that. Okay, so supposedly we don't have to do it. It's fine. Okay, apparently this can be optimized a little. And it's using doubles everywhere. You can switch to floats. Okay, after we've done this estimate axle start, we can do accumulate estimate. I think it would make more sense to accumulate it separately, or whatever. Let's keep it like that. And here we actually don't need to go through all columns, only n of them. I plus 1. Yeah, because I don't want to store the extra unnecessary state. Because we are not storing them, we also don't need to do this stuff. Nice. Okay, apparently we need to pass delta t here, because it's different for every estimate. Oh well. Let's do all of them. Okay, this is actually, I think, correct, actually. Can even do this. Yeah, and that's pretty much it. The step function is complete now. This accumulate estimate updates the height and velocity. Okay, so this is our wave class, tiny, 40 bytes. Now we want to see how it looks. Go into instruction. Our instruction has a widget. Let's add a wave here. Okay, I will change the units. I just want to use something very similar to what we had. To what we had here. I think also when we construct it, it would be good to initialize this state somehow. Okay, that should initialize correctly sized state. Okay, now when I draw the card, let's draw condition. Okay, we have these xmin, xmax, xrange, xcenter. Let's use those. Why is it const? Oh yeah, because we are drawing it. Is there a const span? Maybe that. Okay, and all of the amplitudes should be at 0 initially. So we are not seeing anything. For fun, I will just say, okay, I cannot really change it here. I need tick function. So this is our animation. And we should probably throw this out of balance a little bit. First of all, let's keep animating and let's initialize it in a more interesting way. Like that. Check this out. We have some sort of a wave. It's propagating on all of the cards. But when we zoom in just to see one of them, looks nice. So I see some numerical issues like the amplitude is going down. Maybe if we made it symmetric, it would stay at 0. Okay, so the water is not going to wave here, it's going to splash within this glass ball anyway. So this, instead of this water, we will have this. Looks alright. Looks very alright. I think if I copied the other parameters from JavaScript, because in JavaScript I used much lower delta x. Let's try that. Then the wave will propagate 10 times faster now. So it was behaving like slow motion wave, slowly pushing through the water. I really dislike that. Stuff on screen is often slowed down artificially. It's still too slow. It still should be faster. We will make it faster. This is the numerical issue we have now. It just keeps climbing. Yeah, I need to add some normalization. Okay, if I slow it even further, and should probably also reduce the number of columns. Yeah, now it got flat so quickly that we barely saw anything. A more interesting state. Yeah, it really tends to gravitate down to negatives. We will fix this, no worries. This should be 30. They went down too fast now. Yeah, this vertical velocity is never cancelled. So the case where it stays stable, it's actually super lucky, because normally the errors should accumulate.
I have just a meeting with Post-Chag, PTTC student. I'm supervising as part of my magisterium.
Oh, this is actually fascinating. So how does he work?
Darshanome 117 says,
Hi.
Hi.
CP Chica says,
I'm rather spending 2 years to write that code myself than using that whatever you want to call it.
Interesting. Interesting. I feel that it totally fails in larger code bases. I mean, not I feel, that's the case. Like when you have larger code base, ChatGPT will just mess up stuff. It tends to do that.
That's just one specific guy I don't think has been too good.
Darshanome 117 says,
How did you create such great assets for the Automat?
CP Chica says,
Others are on level of more experienced junior devs, early days, mid-levels.
Yeah, it doesn't seem like AI really changed that much. Darshan, you asked about assets, so it depends. A lot of the stuff is actually done by code, so the vectors, the textures, a lot of the code drives the drawing, and because of that it's very high fidelity, very sharp. And when it comes to textures, it depends. Some of them we process in GIMP, Some of them we like GIMP, Krita, and probably some more. And some of them we do with the help of Stable Diffusion, although it's not quite Stable Diffusion. Just image generators. Image generators are super nice. If you go some streams back,
There is still some natural human factor in post-Chad PT generations.
so if you go some streams back, you will see like the streams where we generate all those images.
Dashanoni 117 says,
So you are not using the SVGs or PNYs.
So I do use SVGs. It's just that... Where do we have it? Sorry, let me look around here. Print instruction, draw flag, draw condition codes. Okay. Oh, for instance here, we are using SVG path, but we are kind of... We're not using SVGs directly. I think there is one place where we use SVGs directly. I think the eye of this bird. We have an SVG file here. So this is the only case where we actually draw a proper SVG file. Usually we use SVG paths, because SVG paths are very compact and very expressive, and there are plenty tools to work with them. Yeah, like those drops. Yeah, those are those drops, actually. This is the...
TP Chica says,
And also I asked Robot to quickly verify some allocation techniques for matrices for some rendering interface. It confabulated following. Char.
Alawait would be Malik size of Jar.
Char Artwad Malak size of Char.
Okay, I think I know what could be wrong. What kind of model are you using? Because there is huge difference between them. This is like night and day. Like some of them will just make up code, and some of them, the best ones, will just mess up your code, but the code that they make up actually kind of makes sense.
Yumini Claude.
Okay, so they should be the best. Okay. That is troubling. And both of them are very good.
And kind of switching to Mistral with Lechat, but
I try to follow what's happening with the models, but it's too much information for me. Recently there was again OpenAI doing stuff, but OpenAI keeps claiming new breakthroughs, and it's still kind of the same. Okay, waves. Let's keep improving them, or maybe let's submit the current stuff that we have.
Dashanoni 117 says,
why don't you use something like this to test your code?
URL. CP Chica says,
OpenAI always hit or miss, especially when it comes down to like high-level overview.
Yeah, and they do a lot of kind of scaring, like they spread a lot of fear around AI unnecessarily.
But Gemini has had rot past with CP code when it misses pointer in direction so often.
I wonder where the Z index is rotated here. Whenever you do this kind of rotation, where you have HTML objects that should rotate, where is this? Oh, this is GL. Yeah, I don't know what's that. It's definitely not related to Automat. Or maybe, let me take a look. Is this some kind of game that... So what do we do? I have no idea. It's some kind of... It's not a game, it's probably some animation, like fancy animation of a library, probably. It's a very fun marketing, I like that.
Speaking of testing, how hard would it be to hook up Automat to the FTL style game?
FTL is largely story-driven, so for those story-driven games, I think we would need agents. We would kind of need to bite the bullet and put AI in Automat. In terms of hardness, I don't think it would be that hard. We already have functions for scanning the screen, so we could scan the key pieces of information. But having an AI for making decisions where to go, that would be big. Representing the state of the ship is going to be hard. We don't have any facilities for that. Like, storing stuff in the registers probably wouldn't make it, wouldn't be enough. Yeah, but FTL would be a nice game, because FTL is highly punishing, right? It kills you even if you are playing it right. So it's a good benchmark for playing games, I guess.
Would mostly needed you fighting for me for those achievements that have a requirement for long fight that are only viable on like Sector 67, maybe even on Starship fight.
Dashanone 117 says,
Could you show how the bird works?
So those FTL, yeah, this is like the perfect use case, like those crazy achievements. I think game developers, sometimes they forget themselves when they design achievements. There is a bit of math inside the bird. We have bird development on streams, actually. Those are some of the earliest streams, I think. I can close this. So the amount of code is massive. It is just the shape of the device, this path here. And the way we do it is that when we take position of the mouse, we find the center of the eye, we kind of model this as a 3D problem where the mouse is on a flat plane above the bird, and we are finding the angle from the 3D angle. We are pretending this is all 3D from the center of the eye to the mouse, and based on that we are squeezing the iris of the bird, and we are not doing this correctly. This is not a proper 3D kind of transform, but it just happens to be... It just happens to look nice. It just happens to look almost like a 3D, like a proper 3D transform.
What do I do in Automat?
It records key presses. So it's a macro recorder. It's an object that manages other objects. So when it's near a timeline, it will connect to the timeline, and when it's activated, it will record sequences of keystrokes. When I press this, play this back now, it moves the screen around. Or it can also type stuff. Yeah, I'm not typing, my hands are here. Yeah, there are so many bugs. So many bugs. So when I hold the bird, you can see that there is this jumping animation when the timeline, the text, when it moves. It's not animating smoothly, it's jumping. I thought I fixed it already.
Did the Automat click or the stream?
Yeah, the glitches are kind of a built-in feature to increase responsiveness, so that when I zoom in, we don't render everything, because many widgets are kind of expensive to render, because everything is an SVG. Not SVG, everything is drawn using vector graphics. It's kind of slow. So we have some mechanisms to hide the slowness and to just keep it fast. Oh, waves started moving again. Anyway, I wanted to rename this to tick.
CP Chica says.
In FTL, since you have mostly state machines that fight so like shields. Guns, shield working, shields, drones. That could be handled easily if it can manage Skyrim grinds.
Sananansha 17 says.
Maybe you should fix the sharpness up to some zoom levels.
Yeah, I think about FTL. In FTL there is this management of energy levels. I think that one could be... Even if Automat doesn't play the game completely for you, it can still probably take care of the power management. I think that could work. Like, you don't always need, highest levels of shields, like you say. We could keep just the bare minimum, shield level, or bare minimum level of something like oxygen, to keep your people from suffocating. And when they start suffocating, we could, before they start suffocating even, we could raise the oxygen levels. Just to save energy. But the stuff that you're mentioning, I'm not sure. What do you mean? When I play FTL, I usually just build large ship, power all the systems that I need at the time, and just try to survive the fights. And during the fight, I'm not a pro player, so I don't know any kind of techniques for maximizing your chances. But I know there are some places where you have to respond quickly to stuff that's happening. Like if there are torpedoes shot from another ship, you have to raise your shields very fast. Or not torpedoes, I don't remember. Yeah, I'm probably speaking misinformation now. Hi Mahatma. Mid-level web developers. Maybe, you know, there is still somebody needed in the chain, somebody who's going to explain to the computer what needs to be done. I think people who don't work with computers every day, they still need somebody, some assistance, essentially. So even low-level kind of programmers will probably still be necessary just to drive LLMs.
But how does the Automat know what's happening inside the game, like someone is shooting, etc.?
So we have this. So when I have a browser and, for example, that game, make this smaller. Yeah, like this. We can do OCR in Automat. It doesn't work too well on transparent backgrounds.
Mike says,
Hi everyone.
Hey Knight.
Wine.
Hello back. You can even see the glitch that happens when background changes here. It's recognizing the text mostly correctly.
CP Chica says,
In ETL, I press only prefer. Burst laser L3, L2.
I'm reading the TTS is glitching out, but yeah, there is the. I think the hardest phase is the initial phase where you build your setup. If you have your ideal ship set up already, I think then it's much easier to write a bot that would control it.
Shanone 117 says,
No, I wanted to say like someone shooting, we only hear gunshots. No view in the game.
We could add audio capture. That's totally doable. I mean, could. We don't have audio capture, to answer your question. change the signature.
TP Chica says,
If you get weapon pregniter by like Sector 3, you have like 75 more chance to get to Sector 8 and like 50 chance to win against Starship.
Yeah, because you're... I know this mechanic, it's very common in games. This is the initiative. If you have essentially a turn-based game, and FTL is almost like turn-based, I'm not quite, but some approximation of a turn-based game. Having the first shot is like being half a round ahead of your opponent. You take less damage, you just end fights more quickly. It's big and it's often unappreciated by players. A lot of the games have this thing. In Dungeons and Dragons, it is very, very visible. If you can end the fight in one round, the initiative is what decides whether you take damage at all or not.
Darsha917 says,
I think Automat is useful for slow-paced RPG-type games.
TP Chica says,
I don't know why they coded enemies to always have like 50 for first day game point given.
Maybe it's specifically because this initiative would make the game too easy. You know, if you just got a bunch of very cheap weapons that can shot before your opponent shoots, and you can get just so much firepower of those fast weapons that you can kill the opponent before he fires at you. Yeah, then it makes many encounters very, very easy. I don't know, or maybe that's not the reason. So Darshan, you mentioned RPGs. There are a couple categories of games where Automat could be used. So my favorite actually is something where Automat doesn't work at all yet. They are logic games. In my opinion, they are the most rewarding to automate. If you have a game that requires you to think a lot, like really, you know, solve the problem, and each stage is incredibly complex, it requires a lot of mental effort from you, then writing a program that can, for example, simulate thousands of solutions and just pick the best one. This is the nicest part of game automation, automating logic games.
Oh, wait. I once beaten Starship with base crystal first ship type B layout, with 4 single-shot lasers, by chaining them into machine gun-like pattern acrobatic.
Yeah, so each of them takes one shield away. Yeah.
Darshanone 117 says,
Yeah, It should have that, or it's just Windows Power Automate with great UI.
Yeah, I want to have proper turn. So, you know, there are different types of games, and for each type of game, you have different methods for solving this type of game. And one specific, like, there are a couple of algorithms, like search algorithms. Search is big in playing games. Search is the way that computers can achieve superhuman abilities at games. But search requires us to represent the state of the game in memory and then kind of simulating the game many steps, like across those states. We don't have that right now, but we will. That's the plan eventually, to have game state representation within Automat.
PP Chica says.
And Starhip is guaranteed to not have more 3 at any time decays with 4. It would just be OP. What is wrong with my typing today?
Yeah, I actually had no idea this strategy works in FTL. By the way, next game that we'll play after we are done with Skyrim, we still have some macros to do in Skyrim, is obviously Oblivion. I haven't played this in a while and it looks insane. And it has the old school quirky Bethesda feeling, which is, you can see it's you can see it's cheap, but it's cheap in a good way. I mean, the story, the acting, like people are behaving like cartoon puppets, but it's fun. It's what makes Oblivion and Morrowind nice. They don't have to be too realistic.
Dashanoni17 says.
Zoom ins and zoom outs look glitchy.
Yeah. It is glitchy. But there is a choice. Either it's glitchy or it's responsive. Or there is third option, or we spend a lot of work optimizing stuff. And I don't have time to optimize stuff. We're implementing just more and more. Honestly, it's not such a... When you use it, it's not such a big problem because it is glitchy at the edges. But this is just so it works. It runs fast. And when it runs fast, it feels good. Okay, so I am here. I am taking total velocity. But in a geometric way, like treating each part of the wave. So this is kind of like a multi-dimensional... I'm treating velocity like a multi-dimensional vector. Okay, yeah. And velocity at each point is just one dimension. Velocity magnitude maybe would be a good way to describe this. Okay, so if we are stopping, then we should normalize velocity to 0, and I think we should also normalize height. Okay, let's see how this works now. Actually, no, it doesn't work because I need to change this file. Okay, the reason for this is that our wave will eventually just stop. Okay, it's drifting away, so maybe it would be nice to have a method that normalizes the amplitude to have 0 mean.
PP Chica says,
I'm going to go and try out Odin for first since I saw it like 2-3 years ago. And thinking of all building like a 6502 or even MMC emulator. I'm just not sure sold. First make it in Scratch CP project just to have logic in place or not.
$6502 sounds like a CPU. Okay. Yeah, I took a look at Odin and it's like... it looks very interesting. It looks very interesting because it's very boring and very few languages are able to do that. It's like whatever you think, whatever feature you think, it's Odin has it implemented in exactly the right way, like the way that you would expect it to work. Just takes all of the most reasonable approaches, most reasonable takes on every language feature, and that's it. That's Odin. Feels a lot like C++, but modern C++.
I liked PDR syntax from Quick Look.
Let me check the dash. I don't recall dashes. Oh, so this is how you mark pointers. Yeah, it's nice. It kind of creates the... instead of following in... So the reason for star was that I think it was the end of the arrow. So when you have a pointer, the pointer points somewhere, so when you look at a pointer, it's like a back of the arrow. This is how I always imagined it. And arrow is also nice. Or maybe it's not a pointer. What's that?
I never really understood you why take reference from left and not dire from right.
Hey, actually that makes sense. Yeah, that would create this spatial relationship. That the pointer would be on the left of the object that it points to. Ah.
Same with channels and go long. You pipe in towards left, but you don't pipe out towards right.
Yeah. I think I will take a break. I need to grab some food and then we will come back to our wave simulation. We need to do this 0 mean amplitude. And I can do it right away because this is correct.
Then we rewrite Windows API in Odin.
It's definitely going to happen eventually. One thing I don't like about the wave animation is that because we are simulating this numerically, it's animating slightly differently in each instance. Still animating. Come on, that should be enough. I think if we introduce damping, maybe then it would work better. Okay, it's very, very subtle damping, or not so subtle. This should stop eventually now. Okay, it stopped. Nice. Anyway, I will grab some food and be right back. I mean, I'll be back in 30 minutes. 30 minutes sounds reasonable. Is it running? It is. Alright, we are back. Don't need this. So what was I doing? Yeah, I've added the exponential damping. I think it would be nice to move this into some kind of function. Like, damping could be... What is the right place to apply damping? Maybe after we do this step. How does it work? This here. So damping is also something that influences the return value of wave. So I think it should be part of the wave. Yeah, damping should happen before we return from tick. That's what I think. So let's add it here. Or maybe let's call it half-life. We could initialize it to not a number. Or maybe 0. Let's say if it's 0, then it means there is no damping. And we need to change the order. Yeah, looks good. Looks good. Now, when we initialize the wave, it should be somewhere here. Let's say it's 1 second. Okay, I will copy the code from somewhere else. That one is too complex. This looks like what we need. So we need to take the time, dumping half time. Sorry, no. We take dt on the top, on the bottom we take dumping half time, but we have to multiply it by, or divide it by some logarithm of something. Maybe this, who knows? We use some of those logarithms here, so maybe this will work. I mean, it's hard to say if it will work properly, correctly or not. Whatever, we have something. We don't need velocity, we have velocity. We need to access n. I will dump this to console just so that we can see that it's not too large, too small, that it's not negative or something like that. I think this is way too small. Way too small. Yeah. And it's super tiny, this damping factor. This is... it's not how we should apply it. We should apply it to delta, which is target, is 0, minus current velocity. Yeah, it quickly stopped. It looked very nice while doing so. So this seems to be somewhat working, but I need to multiply some part of it or divide it by this logarithmic thingy. Is the value. The value is also very close to 1, so it's hard to visually say whether it's correct. I think that was faster, so maybe that's good. Okay, we can remove some negative signs. So instead of doing this exp m1, we can have just exp f. And now we don't need to add anything. Yeah, it's easier when we are approaching 0, so less unnecessarily complex math. Yep, and it disappeared. Yeah, I guess it's fine. We need to probably remove the includes. I think this kind of makes our simulation work. So we should probably now... Okay, now we will do something new. We need to create a widget for this thing here, for the condition code. Condition code widget. This is what we need. It's a big refactoring. It's necessary. The wave should be within this circular thing. Yeah, we have to do it. We already have this idea of having an immediate widget. So this condition code widget needs to edit state which resides outside of the widget itself, I think. The way that we solved it for small buffer widget is that we introduced an interface for this managed object. Okay, and the instruction itself implements a buffer. Oh. Alternative to having so many interfaces everywhere would be to have functions.
I have one problem with Odin.
What's that?
It's new.
True. So interoperability should help with that. I mean, the fact that the LLMs don't work well with Odin, yeah, that's unfortunate. But in terms of binaries, I think it should be able to use most common common libraries. So how is specifically the newness of Odin a problem? Is it just lack of Stack Overflow corpus, or is this something else?
URL.
Well, it got this. No Vulcan.
I mean, it has the default Vulkan types. It doesn't have, I guess, any libraries on top of Vulkan. Long time ago, I heard Vulkan is simple, but then you see 3000 types.
I can seem to create even Vic instance to begin with.
So to create VK instance, so on Linux, I guess you would need xlib, yeah. I think from xlib you can get some kind of handle that will allow you to create a... Okay, there is nothing here.
But after that it falls apart.
Yeah. GLFW? I mean, yeah. So after you create Vulkan instance, you need to get the physical device and then device and then surface. But the hardest part, I think, is getting the surface, because surface requires you to interact with windowing APIs, OS-specific APIs. So you need to somehow pass the handle to the window. It looks like a lot of auto-generated stuff to me. It doesn't look like Odin native.
Correct order would technically be instance, surface, devices.
True. Recently I've hit some weird... Yeah, I think I've even recorded a devlog about this. I've hit this strange case where if I get the XCB handled slightly differently, the NVIDIA driver just disables the, I think, the present extension. So it still allows me to create a surface somehow for this window, but without the present extension, which is... I actually don't know what it's even meant to do then.
In my worldview, why even create devices if they can't present to the surface?
Yep.
Actually, why even use Vulkan if you can't present pixels? Throw it into error and fall back to something.
3 GUI widget. Some condition codes I remember somewhere.
Okay, speedrun challenge. Get Vulkan triangle rendering while my food is heating up.
This is impossible. Even like showing Vulkan window is a week-long process, and you need good materials.
Copy. Pasta done, no.
I wonder how many independent Vulkan independent Vulkan clients actually were ever created. Because you know, the people who wrote the books, like all of the people who read those books and implemented Vulkan, they basically took the same code and they just retyped it over to get Vulkan to work. It's like a genetic tree of Vulkan implementations, and I wonder how many roots there are, how many people who actually tried to understand it and write the window code from scratch.
Nah, JK, I'm not tearing that mess down to make stuff that I want. Okay, let me lessen the scope. Native Win32 windows should be doable, right?
Yeah, that one should be. Okay, we can get rid of that. How do we draw condition codes? So we need to iterate through tokens. And if one of them is a condition code, then this is what we do. Okay. I will keep it for now. Okay, this is massive. Okay, we'll move the constructor around. Token dot condition code. Oh wow, there are some instructions with fixed conditions. Yes, there are. So our condition code widget must be able to also show those. Yeah. Okay, token positions are defined here. Okay, okay. We can make this work. Whoa, what happened here? So we create condition code widget. Yeah, we can do that. That's fine. There should be something like cast in this class. we need to call get immediate. Yep. Let's move our condition code widget here at the end, and now we can access internal properties. Okay, so within the widget we have a function that allows us to say to get the current condition code. When I try to build it, it's definitely going to fail because I didn't fully implement this interface. I will ignore those things. I will just draw a black circle right now. We'll move this draw condition code. We'll actually remove this function. We'll move all of this into this method here. We need to take care of positioning this thing now. And we're not even visiting this. Nice. I think that was in the tick function. Yep. I think this fixed condition may bite us. I really need to figure out how to show this. Maybe they should be frozen, just like registers. Yeah. I think it's more natural if the origin of the widget is actually in the center of the widget, not in some corner. A lot of scaling and transforms, they are just easier then. So I will try that.
I have failed. There goes my alarm.
With Win32 window? This is something that the language model should do. Or did you actually attempt to do Vulkan triangle?
Just window was too easy.
Well, your chances were low then. Without a library? Absolutely. course. It's offset now. But now I can say this grown as widget. Actually, let's also handle this fixed condition. Okay. I can just get rid of this translate. And probably also get rid of this save and restore. Probably just get rid of this altogether.
Why are you using C-style casts? Can't you dynamic cast the type Z86 code?
Speaking of those casts, I'm actually going to migrate the type system of Automat to LVM style RTTI. There was this nice article. I think people in game dev, they use something similar. They don't use the C++ LTTI because it's the dynamic cast is just outside of your control. And it's nice to be able to do some sort of reflection. Very basic reflection, but still. So I'm actively removing dynamic casts. I have 62 left. There are at least 2 places where I actually need a dynamic cast right now, but otherwise, nope. most of them can be removed. Okay, so the condition code seems to be drawn nicely now. I zoom in, yeah. The pixelation effect, it can be seen, is separate from the card pixelation. And I guess this is rather heavy drawing operation, this button here. Okay, now that we have a widget, we can add the tick function. Okay, so when we draw this stuff, how do I want it to look, actually? The central symbol. Have this symbol radius. Maybe we can use that, and symbol oval. Okay, the waves should be waving now. A little bit at least. Yeah, they are. Again. Yeah, they were moving. They were.
I gave Automat a quick look. It looks oddly similar to Priority.
You mean the way that Python manages types? Just Python C API, I guess.
Yes.
I guess that's good. Yeah, it's fascinating. It will be nice because eventually we are going to add Python interface to Automat in a similar way that we have assembly. So all of those should be usable from Automat. I forgot about this part. Yeah, we have a nice wavy surface now. Now, what will happen if I skip this move too? Okay, now it starts at 0. An idea how to draw this. I could either play with clipping or stuff like that.
Can some similar system to R2E be used to avoid the throwing in CPP?
So honestly, yes, you just type F no exceptions and your exception save now. Yeah, exceptions are super messy to me. It's very hard to do anything really without while still being confident that it's going to properly finish. I know. So for throwing from constructors, I would honestly just split the initialization into separate functions that can that actually does the heavy work, and where handling exceptions is easier. Yeah, there was a nice shape here. I think it would be nice to add some sort of continuous wave. Okay, I want to add the movement. So when I move this around, I want to slosh around the water inside. Water, this black thing.
But say like a type where error occurs in last step. For example, Vulkan abstraction types, VKKA usually comes last. And if it fails, you either assert and exist, or throw and deal with it higher up in last step of construction, that is.
Yeah. I know the issue. So in Vulkan, sometimes changing some parameters will allow you to properly initialize, but some kind of fallback. I know what you mean. I'm not so sure, but it sounds like some nested objects would be the solution. Maybe the state which was already finished could be encapsulated as one object, and it would be like this Russian doll style kind of multiple structs embedding one another, and as long as the inner structs are properly initialized, the outer struct can attempt different strategies of initialization, or it can even reinitialize some of the nested state. Yeah, I'm not sure. Honestly, I'm not such a big fan of object-orientedness. Maybe it works well for Vulkan. I don't know.
Im Kindorf aching toward rust result type.
Yeah. So one thing I would think of are, so what are the strategies for constructing the object that you have? Like, for example, there is a default one, there is like fallback A, fallback B, and we want to try default one, then fallback A, then fallback B. So for each construction strategy, we will have some. We have to kind of come up with something that includes what's unique about this default strategy and what's different about fallback A, fallback B. So parameters.
If let error, if let some syntax.
In terms of reporting error, this can really be just about anything. I think for Vulkan pointers would work nicely because you pass this stuff around a lot. You cannot really copy it, you don't know how large it is, so just passing an empty pointer is probably good enough as a failure indicator. If the construction can fail in many different ways, and depending on the failure path, different fallback will be applicable, then maybe it's necessary to distinguish the error types. But I wouldn't do this normally. And I think Rust result includes error code, right? Yeah, it also has an error. Yeah, that should also be fine. But normally I even wouldn't pass the error code unless the error code actually means that I can do something differently in code. For error messages, I just use strings. It would be nice to have a better type for error messages, but so far string is good enough. Yeah, I wish we had something better. Okay, I removed the dumping now. So now we should have infinitely oscillating wave, possibly. Yeah, it was nicely oscillating, but it stopped. Now it's
Stream view. We have something better.
string view is bad for error messages, because for error message you need to construct error message dynamically, because this is the place where you can provide information for debugging. So it has to be flexible. And string view doesn't own anything. It's... oh no. I was thinking more about something like HTML, where we could provide rich information. Like, if you have X and Y, maybe you could annotate them somehow so it's easier to copy and paste. Or the code location where the error happens could be an URL into the code. This kind of stuff. This was a pretty nice wave, actually. Here is what I will do. Or not. No. So now we have a wave that slowly stops, and then we will modify it. Come on. Okay, that's taking too long. Let's do 1 second. Adding half doesn't change anything. Maybe instead of modifying amplitudes, I could modify velocities. I have no idea what this will do. It may be too large. Okay, it's not too large. Far from it. Let's make it 10 times larger. Looks cool. We could increase the number of points. But with 30 it behaved pretty nicely. I don't really want this wave to be capped at 0 here. This is wrong. I don't like it. Yeah, I want it to shift from side to side. This is very liquidy. It's a common thing for liquids, this shifting. So start angle will be let's try this. Okay. It really pays to have decent functions for working with trigonometry. This 2 degrees negative, and a class for representing angles. Super convenient. We get some glitches. Yeah. Okay, I think that was the reason. I wonder why it blinks every now and then. Huh. Again. We must be constructing this path in the wrong way. Maybe because we are adding a couple of points. In the same position.
I kinda seem to like just files.
Oh yeah, I remember. It's... I think... Yeah. They sound like something that could be useful, especially if you're new at a company. It's disappearing. Only this black section is disappearing.
I used to have like you have run. Files all over the place, but this, it's convenient if you don't mind Rust part of it.
Not a number. How? Okay, it has to be this. So just files. Cool. That would be nice if just was part of the standard operating system. If it's a dependency, no. Just another thing that has to be installed on every machine now.
I like it because of Windows. Make file. And I also don't like telling user to download X to get something. This I can put in script and remove binary after I don't need it anymore.
Well, yeah, that's true. But you still have to tell the user to install just. Okay, so cosine was -1. Okay, maybe it is subtly below 1.
I admit to them that if I get binary from GitHub, which is statically linked, there's some stuff that they can move.
Yeah, I mean, I'm not complaining about just. Yeah. Oh yeah, it's below -1. Maybe only that it would be nice if just was part of the OS, like expected on, but that's just impossible. Something that you would find on Windows, macOS. It would be beautiful. It could replace a lot of make usage. I could obviously use it in Automat to build it. It's going to be... it's going to look strange, this value. But okay, let's see how it looks. Yeah, I think I should print it in hexadecimal. How many bits is that? So here we have 8, 16, okay, we have 32 bits. The value of E in binary, it's this 1110. So I guess it's lower than -1. I will do this. I think this subtraction is causing issues. So I will do clamping here. I guess adding will also have this issue. So preemptively, I will put clamping here. Now it should be good. Yeah, and the issue does not happen. Now let's make it faster. So this column spacing, maybe we can drop this mouse. We have damping, right? Maybe it's good enough. Okay, next thing I wanted to do is moving. When I move this, the liquid should slosh around. I can actually push this, so this is now part of Automat. It's animated wave. But we are not finished, we still have this movement. I think we had something in widget. Transform updated. I want to see if this is actually being called. Nope. At least not when I move stuff around. I can just do recursive transform updated, and that would be it. Okay, so when I move this around, transform updated is not being called, even though it moves on screen. Which is probably wrong. We have this object, for instance, and should be calling transform updated when I move the screen around. I am not interested in maybe I am interested in transform updated. Okay. Okay, this is just some epsilon, minimal epsilon. Okay, so whenever transform relative to root updates, this is when I send a notification, like notification when I log a line. Yep. Smooth. Okay. Let me find my code for sloshing around. Okay, this is it. Some things are easier in C++. So we don't need to track this movement X. We are already doing it.
Do you by chance know what's the name of type system Rust uses?
I'm not sure if it has a proper name. I just heard trait-based inheritance because it's trait-heavy, but there's nothing really unique about traits. I know. Okay, we are iterating in a different range.
Henry Milner type system OKAI was useful once.
I hate eponyms, they are totally unhelpful. And especially when you see an eponym with like 3 different names, which is independently discovered by 3 different people. And all this stuff is based on ancient Greek ontology still.
It's all based on Boolean algebra.
Oh, inheritance? Inheritance is not quite.
Well, isn't type system just a set theory applied on top of Boolean algebra, only being used in practice by computer science?
So there are two parts there. There is the idea that objects form a hierarchy, and there is the formalism, just wrapping this in a mathematical language. The idea that objects are based on a natural hierarchy and they are composed of substances and they have sorts of like essences within them, this is ancient stuff. And then wrapping something like that in the language of mathematics, it's not a big deal. It doesn't bring anything new to the table. Okay, moving stuff to the left. Wow, what's happening there? It doesn't have the effect. I mean, there is some movement here. It's not what it should be. I think I know. Yeah, this is because I have stuff normalized to 0. Sometimes it will slosh, but it's mostly accidental. Okay, so when doing this sloshing, I need to pretend that I need to add some bias to the height. And then I need to subtract it. Something like that. But this bias, I think it would be nicer if it was different depending on the position within the orb. Yeah, now it's looking much nicer. Okay, it is doing some crazy things. Let's do this. Float x is equal I plus half divided by number of is multiplied by 2 times symbol radius. So if height goes from -1 to 1, then we should add 1. Now we have a number from 0 to 1. This is not entirely correct. So the height of a column of water at any point is going to be this height plus symbol radius, because this is how far from the bottom we are, minus the part below. Yeah, which is this. Very strange. Should be correct. So waves don't really have height, they have amplitude. Still not good. I mean, we are getting some sort of wavy behavior now. Let me see. Now the waves should curl around the center of the orb. They are going to look strange, I think. Yeah. Okay, this is number from 0 to 1. I want a function that goes like this. It should go from zero to wave n. This is our I. Something that goes like that. It should be very close to symbol radius most of the time. Okay, this is a polynomial, so this will be I times I minus wave n plus 1. Okay. Small thing times something small Just one more thing I think we need to do. And that would be to carry the max height. So here this height is not, it's not really height, it's amplitude. But we are converting from amplitude, we are pretending it's volume. Yeah, it's volume of water. Okay. If new height is greater than max volume, oops, should remove. Yeah. So we are crashing somewhere. I think this has to be one of the square roots. It's the only option. But it also has no right to crash. Maybe that. Okay, that was interesting. I have no idea what happened here. Okay, any movement causes these to stop. Ah, we have to multiply this. And probably we have to divide it here. Okay, a lot of those artifacts actually don't understand why do they happen. Something is wrong with our drawing code. Okay, I will open this on Twitch and see if I can figure out what's wrong. Okay. Okay, I think I know. So I'm drawing a point here, then here, then here, then here. No. The first point? Impossible. The shape of the... path is at fault. So when a point is disturbed from its default position, it's shifted normally up and down. But because this is all within a circle, I warp some of the points, like the ones closer to the end, so that instead of moving up and down, they move along the radius of the circle. And the closer a point is to the edge, the stronger this warp effect. So this is why I have this. I think this is just a drawing artifact now. This is why I have this funny equation here. Oh, look, and I can break it completely. I just hope I didn't broke anything right now. Still seems to work. I wonder if I just removed symbol radius, I replace it with 1. So this will be 1 times 1, 1. Disappear. Okay, this still works. I have to do this differently. So the last point should move along this trajectory. Central point it's actually kind of hard. That should help with debugging. Now it will be drawn as a very thin outline. Look at that. There is a line here. Maybe I can skip this close. Maybe this close does something weird. Apparently it does, but we should close. Yeah, symbol is an empty path. Okay, this should be false, and then now we can do close here. That's because arc2 opened another path, another contour. Okay, it seems to work like it should, but we are still getting those cutouts at the bottom. Super strange. I will open Twitch again. You can see how large is my latency now. It's very low. Okay, so I'm starting here, I'm drawing line like that, and for some reason, instead of starting somewhere here, I'm starting here. Oh. Oh no, Chrome crashed. such a strange thing. Now I am adding a point. Sorry, not point, a circle at the first point. It's a little bit too small. Okay, I need Twitch again. Aha. So the first point that we are moving to is just here. Okay. It's just that we have a very large difference between first and second point. If this is the case, then okay, then this will not change anything. But it is kind of strange that when we are moving like that, the edge is kind of so low. The final edge, it should be near the top when we are moving to the right. Seems to work for other columns, not for this one though. Maybe the rowing code is okay and the sloshing is wrong. I'm not sure. Maybe this will change something. I'm not sure if I'm dividing the right thing. Yeah, it's still going down. Okay, these new heights that we have here, it is clamped to max volume. This is how I should calculate the volume. Something like that. Just to make it symmetric. Okay. Now it behaves properly. So this is how it would behave if we had like constant acceleration to the left, constant acceleration to the right. And when the acceleration, I mean, I don't track acceleration yet, but if I did, this is how it would, how it should behave. Which is super nice. Go back to the drawing code. Let's divide this by 2. That should make the shape more yin-yang like. Okay, not quite. if I divide it by nothing, how it's going to look then? Not great. Somehow the C++ code works better than JavaScript. This is a rare occurrence. It behaves nicer. So if I let it stabilize, we should drop in a moment. Yeah. Let's get rid of the circle. You can change the style to regular fill. It's kind of late. Okay, I will just do one more thing today, which is to track acceleration instead of velocity. Is delta x divided by timer d gives us current velocity. I'll just make it a regular float. I'm not sure how it's going to work. The units are totally wrong. Acceleration... yeah, it's a totally different unit. Yeah. Now I'm trying to track the local acceleration within the reference frame of this thingy, and I'm doing this using just random numbers. Okay, seems like it behaves correctly when it stops. It sloshes in the other direction. It's much more... it's more than responsive, it's kind of chaotic now even, but this is good because I think this is how water pretty much should behave. For fun, could increase the number of points. Our simulation is fairly fast, we are probably limited by drawing. So we should be able to draw, I mean, hopefully we should be able to draw even thousands of points. Wave simulation is very fast. When I have so many points, the simulation suddenly becomes super slow. So dropping this down is probably the way to go. It's funny that for this simple animation we used pretty nice math. I mean, it's pretty efficient. I think we'll use a lot more waves in the future to do all sorts of visual effects. Probably actually some stuff that I had here about this sloshing. It's probably a good idea to generalize this, to move this into the other class. And actually I was also thinking about something else, about drawing this as a water within this water bead. So the symbol should be not overflow. Okay, I think I know what the symbol could be. The symbol could be like the Ghostbusters, the crossed circle with a drop inside, so no overflow. Much simpler. And this, we are going to use this to draw, to pretend that this is filled with water. But it's kind of too late today to go into that. So I think on the next stream, I guess we will do exactly that. We will fill this with water. We will change this symbol here and here. And for this one, I also want to draw a stain outside. So there is this point here. This is where the overflow happens, when the dial crosses this boundary here. So this is where I want to draw the spill happening. Yeah, and if we simulate this so that it's just filled with water, we don't need to animate this continuously. We can just let the animation finish naturally. Okay, guess that's it for today. See you on Wednesday. Bye bye.